Hi, and thank you for your interest. Today I want to talk to you about a course that we've developed to teach science to non-science undergraduate majors using concepts from everyday life. Our goals are to teach science through everyday examples. Now, we've seen that a lot of undergraduate majors, especially non-science majors at Georgia Gwinnett College, are scared by math and science concepts. So we want to teach them through engaging examples from everyday life. And apart from that, we want to impart problem-solving skills that are also extremely useful even outside the classroom. In order to help us, we have varieties of activities such as interactive demonstration, home-based and low-cost labs, as well as virtual labs that are becoming increasingly important, especially during our current pandemic times. We've also developed an open access textbook as part of an Affordable Learning Georgia grant. This textbook contains 8 chapters, and the first few chapters are about traditional material properties and how they emerge from their underlying constituents. Next, we discuss common everyday materials and how these common materials can actually have a combination of liquid and solid material properties. Finally, we move on to the larger scale, such as the emergence of societies and especially how traffic jams emerge from individual unpredictable drivers. So while these might seem like a variety of different concepts, the underlying theme is how building blocks at various length scales can lead to emergent and predictable scientific phenomena. As an example, look at our first chapter, which deals with the idea of length scales in everyday materials. So on the left, you can see an example of a typical material such as diamond that contains protons and neutrons, which make together a nucleus, and a nucleus along with electrons makes an atom, and arrangement of these atoms in a particular manner leads to the material properties such as the solid, rigid nature of diamond. Next, at the intermediate length scale, we have soap molecules that combine together along with water molecules and lead to the modification of surface tension, ultimately responsible for forming of bubbles. Finally, at the largest length scale, we have the emergence of societies, and a typical example of that is traffic jams. So here students learn how, while individual drivers are quite unpredictable, turns out that many drivers together form predictable traffic jams, and many of these roads together form traffic patterns, and turns out that city-scale traffic patterns are quite predictable from the daily perspective. Now on the left, you can see the contents. So here you can see that there are chapter sections as well as subsections for these individual chapters. Now chapters 2 through 5 are about the emergence of typical material properties. So first of all, students learn about the building blocks of matter, which are the elements and how they are arranged in the periodic table. Next, students learn how these elements form atoms and atoms combine to form molecules, and the interaction between molecules or atoms leads the emergence of typical material properties such as gas, liquid, and solid properties. And students also have access to online activities as well as demonstrations of springs. Next, we talk about common everyday materials such as ketchup or cornstarch in water, and how these common materials actually are quite complex and have a combination of solid and liquid properties. Take ketchup, for example. When you pour ketchup from a bottle, it's a liquid, but once it lands on the plate, it turns out to have solid-like properties. And in a similar way, cornstarch, if you were to just stand on cornstarch in water, which is also known as oobleck, you would just sink like a liquid. But as you can see, this person is running. So if you apply enough stress or enough force, then it responds as a solid. Now, students also have access to low-cost homemade activities such as how to make oobleck using commonly available cornstarch mixed with water, as well as we show demonstrations of silly putty and slime mold. In chapter 7, students learn about surface tension and how surface tension is important for making soap bubbles. Students also learn how surface tension is important for life, such as why plants are able to uptake nutrients due to surface tension and do work against gravity. Students also do a lab on making these huge soap bubbles using special polymers, and students learn how the recent advances in polymer and physics can tell us about how to make huge, stable soap bubbles. Finally, students look at societies. So as a case study, we consider traffic jams. In the model above, in the animation, you see how traffic jams can sometimes appear, and so students learn why traffic jams form, sometimes for no apparent reason other than drivers have different behaviors. And so they learn how, while individual actors and drivers are quite unpredictable, collectively we are quite predictable, and traffic jams are in fact extremely predictable. As a group activity, students form a circle and they see how traffic jams emerge just based on the individual differences between strategies. As a lab, students are able to explore an online virtual lab where they can see how various microscopic patterns can cause differences in emergent traffic jams. Now, during the last 2 weeks, students do a report as well as a presentation. Now, the objectives are that students do a case study on any material that they like, and they learn to write clearly, concisely, and effectively. They also learn how to communicate what they've written to an intended audience. And the activities for this are, during the first week, they write a report or a blog in a popular blogging platform called Medium. And during the second week, they present their work for 5 minutes and take 2 minutes of questions. In conclusion, we have developed a theme for non-science majors to learn science in the everyday context. We've also developed an accessible zero-cost ebook, as well as low-cost engaging activities that can be done at home. Essentially, we can ensure that students still have the hands-on aspect of this course, while also making sure that they are respecting socially distanced guidelines by doing these experiments at home at a very low cost. We are constantly adding new materials, so if you're interested, feel free to contact me at this email address below. And thank you so much for your time. I hope you enjoy the rest of the conference.